On the night of November 29, 1944, the largest aircraft carrier ever built slipped beneath the surface of the Philippine Sea. She had been commissioned 10 days earlier. Not a single aircraft had ever launched from her deck. Her name was Shinano. Her displacement, 71,790 tons fully loaded. A figure that would not be surpassed by any aircraft carrier on Earth for the next 11 years. The Imperial Japanese Navy had spent 3 years and an estimated 780 million yen converting her hull from what was to have been the mightiest battleship ever built into what they believed would be an unsinkable fortress of the seas. She sailed from Yokosuka Naval Base at 1800 hours on November 28th. 17 hours later, she was gone. The weapon that killed her was not a fleet action, not a carrier air wing, not a surface bombardment. It was a single American submarine, USS Archerfish SS-311, a Yamato-class boat with a crew of 287 men, armed with Mark 14 and Mark 18 torpedoes, operating on her 8th war patrol. Archerfish fired 6 torpedoes. 4 struck Shinano's watertight compartments, the very engineering feature designed to make her immune to exactly this kind of attack. Flooded in sequence. Her crew, undertrained and still learning the ship around them, could not stop it. But the real story of Shinano is not the sinking. It is the story of what the Imperial Japanese Navy built, why they built it, what they refused to acknowledge before they sent her to sea, and what one American submarine commander understood in the dark, in enemy waters, that the entire Japanese High Command did not. Every week, we tell the stories behind the weapons, the battles, and the decisions that shape the course of naval warfare. Give the video a like and subscribe if you want to keep hearing them. The story begins in the steel yards of Yokosuka Naval Arsenal, Japan, in the spring of 1937. In 1937, the Imperial Japanese Navy faced a problem it could not solve with existing technology. The Washington Naval Treaty of 1922 had capped Japanese battleship tonnage at 315,000 tons, a ceiling that left the IJN numerically and qualitatively outmatched against the combined fleets of the United States and Great Britain. Japanese naval planners had spent 15 years searching for an asymmetric answer. By the mid-1930s, they believed they had found one. The answer was mass. Overwhelming, concentrated, armor-plated mass. The Naval General Staff issued a classified construction directive in 1937, known internally as the A-140 design series, authorizing the construction of 3 battleships of a size the world had never seen. Each hull would displace 65,000 tons at standard load. Each would carry 9 46mm Type 94 naval guns, the largest caliber guns ever mounted on a warship, capable of hurling a 1,000 or 160-kilogram armor-piercing shell a distance of 42 kilometers. The intent was not subtlety. The intent was a weapon so large, so heavily armored, and so powerfully armed that no combination of American or British battleships could survive an engagement with it. The first hull, designated Hull Number 1, would become Yamato. The second, Hull Number 2, would become Musashi. The third, Hull Number 3, laid down at Yokosuka Naval Arsenal on May 4, 1940, was designated simply as Ship Number 110. The name Shinano would not be assigned until much later. The secrecy surrounding all 3 hulls was absolute. Yokosuka's dry dock was enclosed with wooden screens and canvas sheeting. Workers were sworn to silence under penalty of military law. The Japanese government filed no notification with international naval authorities. The entire program existed officially nowhere. The chief naval architect responsible for the A-140 design series was Rear Admiral Keiji Fukuda, head of the IJN's 4th section of the Naval Technical Department. Fukuda had spent his career refining capital ship design. and the Yamato-class represented the culmination of every lesson the IJN had absorbed from 2 decades of warship engineering. The belt armor on hull number 3 was designed at 410 mm at its thickest point, sufficient, in IJN calculations, to defeat any naval gun in the American or British inventories at combat ranges. The flight deck, when the conversion decision came, would be armored to a standard no existing carrier in the world could match. The competition, such as it was, did not exist. The IJN operated no competitive contractor bidding system for capital ships. Yokosuka Naval Arsenal held a monopoly on construction of the largest hulls. There was no alternative builder, no rival design team, no second proposal. The decision made at the Naval General Staff level was executed without external challenge. Construction on hull number 3 proceeded through 1940 and into 1941 at a measured pace. The keel was laid, the frames went up, the armor belts were fitted in sequence. By the time Japanese aircraft struck Pearl Harbor on December 7, 1941, Shinano's hull was approximately 44% complete. A battleship taking shape in a covered dry dock, unknown to the enemy, consuming steel and labor that the Japanese war economy was already beginning to find difficult to spare. Then Midway happened. On June 7, 1942, the Imperial Japanese Navy lost 4 fleet carriers, Akagi, Kaga, Soryu, and Hiryu. In a single engagement, approximately 292 aircraft went down with them, along with the most experienced carrier air groups Japan possessed. The loss was not merely numerical, it was generational. The pilots, the mechanics, the deck crews, the institutional knowledge accumulated over a decade of carrier aviation. Much of it was gone in 4 days. The Naval General Staff convened immediately. The strategic calculus had shifted without warning. Battleships, however large, however heavily armed, were no longer the axis around which Pacific naval power would rotate. Carriers were. Japan needed more flight decks, not more gun barrels. The question before the General Staff in the summer of 1942 was direct. What assets existed that could be converted, quickly, into carriers? Hull number 3 was 44% complete. Stopping construction entirely meant wasting the steel already installed. Converting her to a carrier meant losing the battleship but gaining a flight deck of extraordinary size. One built on a hull armored to a standard no carrier anywhere in the world could approach. The conversion order was issued in the fall of 1942. Shinano would not carry 46-centimeter guns. She would carry aircraft, or so the plan stated. What emerged from Yokosuka Naval Arsenal between 1942 and 1944 was unlike any carrier the world had produced. The conversion did not strip Shinano down to a bare hull and rebuild her as a conventional flight deck vessel. That would have been faster. The IJN chose instead to preserve the fundamental character of the Yamato-class architecture. The armor, the compartmentalization, the sheer structural mass, and graft carrier capability onto it. The result was a ship that defied easy categorization. She was not, strictly speaking, a fleet carrier in the conventional sense. She was something the IJN's own planning documents described as a support carrier, a mobile armored base designed to receive, rearm, refuel, and redispatch aircraft from other carriers operating nearby, while herself remaining resistant to the air attack that had destroyed her predecessors at Midway. The dimensions alone communicated ambition on a scale no Allied naval architect had yet attempted. Shinano measured 266 meters in length, roughly the distance of 3 American football fields placed end to end. Her beam at the waterline ran 36.3 meters. Her flight deck, constructed atop the original battleship hull, stretched 256 meters and was armored with 75 millimeters of Ducal steel plate. That is 3 inches of hardened naval steel laid directly into the flight deck's surface, designed to absorb bomb hits that would have destroyed the wooden flight decks of American Essex-class carriers. An Essex-class carrier, the workhorse of the American Pacific Fleet in 1944, displaced 27 to 100 tons at full load. Shinano displaced 71,190 tons. She was, by that single metric, 2.6 times heavier than the best carrier the United States had yet put to sea. Her propulsion plant consisted of 12 Campon boilers, water tube boilers that converted high-pressure steam into shaft horsepower, driving 4 turbine sets producing a combined 150,000 shaft horsepower. That figure pushed her designed top speed to 27 knots, slower than an Essex class at 32 knots, but fast enough to operate with carrier task forces in open ocean. 4 bronze propeller shafts, each over 100 meters in length running through the hull, transferred that power to the water. The fuel oil bunkerage, 8,900 tons, gave her a theoretical operational range of 10,000 nautical miles at 18 knots. She could, in theory, cross the Pacific and return without refueling. The defensive armament reflected the lessons of Midway and the Solomons campaign. Shinano carried 16 12.7mm Type 89 dual-purpose guns, weapons that could engage both surface targets and aircraft. Mounted in 8 twin turrets along her hull sides, she carried 145 25mm Type 96 anti-aircraft autocannon in triple, twin, and single mounts, distributed across her superstructure and flight deck edges. That number, 145 individual gun barrels dedicated to anti-aircraft defense, exceeded the total anti-aircraft armament of any single American carrier then in service. Against a sustained air attack, Shinano was designed to generate a volume of defensive fire that her architects calculated would make a successful strike geometrically improbable. Her aircraft capacity told a different story. Despite her size, Shinano was designed to carry only 47 aircraft as an active air group, substantially fewer than an Essex class, which operated between 90 and 100 aircraft in 1944. The logic was deliberate. Shinano was not intended to be the strike element of a carrier task force. She was the logistics core, the armored warehouse. Her hangars were configured not for maximizing parked aircraft, but for storing and servicing replacement aircraft, replacement engines, replacement ordnance, and aviation fuel for the carriers operating around her. She could theoretically receive damaged aircraft from fleet carriers, repair them, and return them to the fight. In IJN planning documents from 1943, she appears not as a combatant, but as a force multiplier, the ship that would keep other ships fighting longer. The armor that had defined her as a battleship was retained, and in some sections reinforced during the conversion. The main belt armor, running along the waterline for the length of the hull, measured 410mm at maximum thickness. That figure requires a point of reference to carry weight. The belt armor on an Iowa-class battleship, the most powerful American surface combatant of the war, measured 307mm at maximum. Shinano's waterline protection exceeded Iowa's by more than a third. Below the waterline, a torpedo defense system, a layered void and liquid sandwich built into the hull's outer structure, was designed to absorb the explosive energy of torpedo hits and dissipate it before it reached the inner hull. On paper, the system was rated to withstand hits from torpedoes carrying up to 350-kilogram warheads. The Mark 14 torpedo carried by American submarines in 1944 contained a 292-kilogram Torpex warhead. Torpex, a British-developed compound of TNT, RDX, and aluminum powder, detonated with approximately 50% greater explosive force than an equivalent weight of pure TNT. The IJN's torpedo defense calculations had not fully accounted for Torpex. That gap between the design assumption and the operational reality would assert itself on the night of November 29th. Construction accelerated through 1943 and into 1944, but never reached the pace the Naval General Staff required. Steel allocation competed with submarine construction, aircraft production, and the repair of surface warships damaged in the grinding attritional battles of the Solomons. Skilled workers were diverted. Specialized fittings arrived late or not at all. By the summer of 1944, with American forces advancing through the Marianas and the Philippine Sea Battle, having destroyed what remained of Japanese carrier air power, the pressure from Tokyo became direct. Complete Shinano and get her away from Yokosuka before American carrier aircraft found her in dry dock. She was commissioned on November 19, 1944. The ceremony was brief. There was no celebration. The ship was not ready, and the men who had built her knew it. Shinano was commissioned into the Imperial Japanese Navy on November 19, 1944, under the command of Captain Toshio Abe, a career surface warfare officer who had previously commanded the cruiser Takao and held staff positions within the Naval General Staff. Abe was not a carrier aviation specialist. He was a ship handler, an officer of the old surface Navy, assigned to command a vessel whose primary function he had never trained to execute. That mismatch was not accidental. The IJN in late 1944 had run short of experienced carrier commanders. The ones who remained were needed elsewhere. The crew Abe inherited was similarly incomplete. Shinano had been assigned approximately 2,515 officers and enlisted men at commissioning, a figure that represented roughly 87% of her full complement. Of those present, a significant portion had reported aboard within the previous 30 days. They had not completed damage control training. They had not conducted flooding drills. They had not run the watertight door closure sequences that would be the difference between survival and catastrophe if the hull was breached. Many of the men did not yet know the layout of the ship they were standing on. The watertight integrity of the hull itself was unverified. Standard IJN procedure for a newly commissioned capital ship required a period of harbor trials, typically several weeks, during which watertight compartments were tested under pressure. Flooding valves were exercised and pumping systems were confirmed operational. Shinano had completed none of this. Many of her watertight doors had not been fitted with their rubber gaskets. Several compartments contained construction materials, lumber, tools, equipment, left behind by dockyard workers who had not finished their work when the commissioning order arrived. The ship was, in the technical language of naval engineering, not materially ready for sea. The reason she sailed anyway was strategic panic. On October 25, 1944, American carrier aircraft had struck the Sibuyan Sea during the Battle of Leyte Gulf and sunk Musashi, Shinano's sister ship, the second of the Yamato-class battleships. Musashi had absorbed an estimated 19 torpedo hits and 17 bomb strikes before capsizing. She was gone. Yamato, the first of the class, had survived Leyte Gulf, but remained the subject of aggressive American targeting. The IJN's Naval General Staff had concluded correctly that Yokosuka Naval Base would eventually come within range of American carrier air operations. A 71,090-ton carrier sitting in a dry dock was an irreplaceable target. The order came down: move Shinano south to Kura Naval Arsenal on the inland sea, where she would complete her outfitting in a more defensible anchorage. The sailing orders were issued for November 28, 1944. Shinano would depart Yokosuka at 1800 hours, transit south along the Japanese coast under cover of darkness, and arrive at Kure within approximately 18 hours. She would be escorted by 3 Fubuki-class destroyers, Isokaze, Yukikaze, and Hamikaze. The destroyers would provide anti-submarine screening. The route would keep Shinano within range of land-based air cover during daylight hours. The transit, in the Naval General Staff's assessment, was a manageable risk. Captain Abe requested a delay. His ship was not ready. His crew was not trained. His watertight system was unverified. The request was denied. The sailing schedule stood. At 1800 hours on November 28, 1944, Shinano cleared Yokosuka Harbor and turned southwest into the Philippine Sea. She was running at 20 knots, below her designed maximum, but sufficient for the overnight transit. The night was clear. The sea state was moderate. Visibility was good. For a submarine, visibility was irrelevant. What mattered was the sound of propellers in the water, and Shinano's 4 shafts, turning at speed, produced a sound signature that carried for miles through the dark Pacific. At approximately 20:48 hours that same evening, the officer of the deck aboard USS Archerfish, operating on war patrol in precisely the waters Shinano was transiting, made a visual contact. A large vessel, multiple escorts, course southwest, speed approximately 20 knots. The contact was logged. The approach began. What followed over the next 4 hours was not a battle. It was a geometry problem. And Commander Joseph Enright, commanding officer of Archerfish, was solving it in real time. Joseph Francis Enright was 34 years old in November 1944. He was a Naval Academy graduate, class of 1933. And he carried with him a piece of personal history that bore directly on what was about to happen. In October 1943, commanding USS Dase on her first war patrol, Enright had made contact with a large Japanese warship, later assessed as the carrier Shokaku, and had failed to close to firing range before losing the contact. He had returned to port, requested relief from command, and been reassigned to a shore billet. The Navy had eventually given him another boat. He had spent 13 months rehabilitating a reputation he believed he had forfeited. Archerfish was his second chance. He did not intend to lose another contact. At 20:48 hours on November 28th, Archerfish was running on the surface, charging her batteries after a day of submerged patrol. The lookout's report of a large contact to the north brought Enright to the bridge immediately. Through his binoculars, he could resolve the silhouette. A very large vessel, flat-decked, with destroyer escorts fanned out ahead and to the sides. He identified it as a carrier. He could not know it was Shinano. What he knew was that it was the largest warship he had ever seen, and it was moving in a direction that, if maintained, would eventually intersect with a firing position, provided Archerfish could achieve the geometry. The problem was speed. Shinano was making 20 knots. Archerfish's maximum surface speed was 20.25 knots, a margin of approximately 0.25 knots. On a closing course, that margin was nearly meaningless. Enright could not simply chase the target down. He had to run ahead of it, submerge, and wait for Shinano to come to him. To do that, he needed to predict exactly where Shinano would be, at what time, and place Archerfish at that position before the target arrived. For 4 hours, Enright ran Archerfish at full surface speed on a parallel course, then angled ahead, calculating and recalculating the intercept. The destroyers screening Shinano detected nothing. At one point, Shinano changed course, a standard anti-submarine zigzag maneuver, and appeared to open the range. Enright adjusted. The geometry came back together. At 2:56 hours on November 29th, Archerfish submerged ahead of Shinano's projected track. Enright brought her to periscope depth. Through the periscope optics, he watched the bow wave of the largest ship he would ever see, bearing down on his position. At 317 hours, at a range of approximately 1,400 yards, less than 0.8 of a mile, he gave the order. Archerfish fired 6 torpedoes from her forward tubes in a spread pattern, set to run at depths between 10 and 15 feet. Targeting the waterline belt, the precise zone Shinano's designers had armored most heavily. 4 of the 6 torpedoes struck. The first hit landed at 03:17 hours, forward of amidships on the starboard side. The second struck approximately 15 seconds later, amidships. The third hit aft of amidships. The fourth struck near the stern. Each detonation carried 292 kilograms of torpex into the hull plating at the waterline, precisely where the torpedo defense system was rated to absorb the blow. The defense system had never been tested at sea. It had never been flooded to operational pressure. The void spaces designed to absorb blast energy were, in several compartments, still dry, because the flooding valves had not been exercised and in some cases had not been fully installed. Water entered Shinano through 4 breaches in her starboard side. The pumping systems activate, partially. The watertight doors in the affected compartments were ordered closed. Some closed, some did not. The rubber gaskets that should have sealed them were absent. The compartments that should have contained the flooding did not contain it. Water moved through the ship in ways the damage control teams could not track, because the teams had never trained on this hull, in these compartments, with these systems. Captain Abe initially assessed the damage as manageable. Shinano was, after all, the most heavily armored carrier ever built. 4 torpedo hits had not stopped Musashi immediately. Musashi had absorbed 19 before capsizing. Abe maintained course and speed. He did not order the ship to turn toward shallow water. He did not request emergency assistance from Yokosuka. He calculated that Shinano's armor and compartmentalization would contain the damage until he reached Kure. The calculation was wrong. Not because the armor failed. The armor performed as designed. The hits did not breach the inner hull. The torpedo defense system absorbed the initial blast energy. What failed was everything aft of the engineering, the untested flooding valves, the ungasketed watertight doors, the undertrained damage control parties who could not isolate the progressive flooding before it crossed compartment boundaries. By 0500 hours, Shinano had developed a list of 10 degrees to starboard. By 0600 hours, the list had increased to 20 degrees. The pumps could not keep pace with the inflow. The damage control parties, working in flooded compartments in the dark, could not identify which boundaries had failed or how to restore them. Abe finally ordered a course change toward the coast of Honshu. Too late. By 0700 hours, the list had reached 30 degrees. At that angle, loose equipment, aircraft, ordnance handlers, and men began sliding across decks. The engineering spaces flooded. The turbines lost steam pressure. Shinano slowed, then stopped. At 10:57 hours on November 29, 1944, 10 hours and 40 minutes after the torpedo hits, Shinano rolled to starboard and sank in approximately 1,400 meters of water. Her position, 32 Degauro N, 137 Degauro E, roughly 65 nautical miles southeast of Shionomisaki, the southernmost point of Honshu. Of her 2,015 crew members, 1,035 were lost. Captain Abe went down with his ship. Commander Enright, still submerged several miles distant, heard the hull collapse on his sonar. He did not yet know what he had sunk. The 3 escorting destroyers recovered 1,180 survivors. They were ordered to maintain strict silence about what had happened. The IJN did not announce Shinano's loss. The vessel that had been the largest aircraft carrier on Earth had existed in operational service for exactly 17 days, and the Imperial Japanese Navy attempted to erase her from the record as if she had never sailed. The Imperial Japanese Navy did not record Shinano's loss in any public document. No official announcement was made. No casualty notification was issued to the families of the 1,035 men who died with her. The survivors pulled from the water by Isakaze, Yukikaze, and Hamikaze were transferred to shore facilities and placed under strict orders not to speak of what had happened. The sinking of the largest carrier ever built by a single submarine, on her maiden voyage, before a single aircraft had touched her deck, was a fact the IJN could not afford to have known. Not by the enemy, not by the Japanese public, not even, if possible, by the broader apparatus of the Japanese military establishment. The concealment held, imperfectly. American signals intelligence detected anomalies. The sudden disappearance of a large vessel from tracked IJN movements. The unusual silence from Yokosuka regarding a hole known through earlier intelligence to have been nearing completion. But the full picture did not emerge until after the war ended. It was post-war interrogation of IJN officers and examination of surviving Japanese naval records that established the complete sequence: the commissioning on November 19th, the sailing order on November 28th, the sinking on November 29th, and the 17-day operational life that those dates enclosed. The Joint Army-Navy Assessment Committee, JANIC, the post-war American body charged with verifying warship sinkings claimed by U.S. forces, formally confirmed Archerfish's kill in its 1947 report. The confirmation gave Commander Enright, by then long since returned to civilian life, the verified record: largest warship ever sunk by a submarine in the history of naval warfare. No subsequent assessment has challenged that finding. What the post-war record also established, with documentary precision, was the sequence of institutional failures that made the sinking possible. They did not begin on the night of November 28th. They began in the summer of 1944, when the Naval General Staff made the decision to compress Shinano's completion schedule without compressing the list of incomplete systems aboard her. The gaskets were not installed. The flooding valves were not tested. The damage control parties were not trained. These were not oversights in the conventional sense. Individual failures of attention or competence. They were the output of a system under terminal pressure. The IJN, in mid-1944, was simultaneously trying to repair the surface fleet damaged at Leyte Gulf, construct replacement submarines, maintain land-based air operations across a contracting defensive perimeter, and complete Shinano, all with a steel allocation, a skilled labor pool, and an industrial base that had been shrinking since 1943. Something had to give. What gave was Shinano's readiness. The decision to sail her anyway, over Captain Abe's documented objection, was made at a level above his command. The Naval General Staff assessed the risk of losing her to American carrier aircraft in Yokosuka Dry Dock as greater than the risk of transiting south with an unprepared crew and unverified watertight integrity. That assessment was not irrational given what American carrier strikes had done to Japanese facilities throughout 1944. It was, however, catastrophically wrong about which threat would materialize first. Archerfish was not supposed to be there. Her patrol area had been assigned based on fleet movement assessments that did not anticipate Shinano's transit route or timing. Enright had chosen to remain on the surface that evening to charge batteries, a routine operational decision that placed Archerfish precisely where Shinano's track would cross. The encounter was not the product of American intelligence superiority or deliberate interception. It was geometry and timing, resolved in favor of the submarine by 4 hours of patient maneuvering in the dark. The torpedo performance completed what the maneuvering made possible. The Mark 18 electric torpedo, which Archerfish carried alongside the older Mark 14 steam torpedoes, left no visible wake. No phosphorescent trail in the water, no warning. The first indication aboard Shinano that she had been struck was the detonation itself. By the time the damage control parties reached their stations, 2 more hits had already landed. Then the ship began to die, slowly, irreversibly. The list grew. The pumps fell behind. The compartments that should have held did not hold. The flooding moved aft. The engineering spaces lost pressure. The turbines stopped. The bow rose slightly as the stern settled. Men moved to the high side of the deck. Equipment broke free. The destroyers came alongside to take off wounded and non-essential crew. Abe ordered his men over the side. The list reached 30 degrees, then 35. At 10:57 hours, she rolled. She went quickly at the end. The hull inverted. The flight deck, 75 millimeters of armored Ducal steel, wider than a city block, faced downward into 100 meters of water. The propeller shafts, still attached, dragged the stern under. The bow followed. The sound of the hull collapsing under pressure carried through the water for miles. Archerfish recorded the time. Enright wrote his patrol report. He did not know the name, but he had sunk. He described it as a carrier, Yamato-class, or larger, in the vicinity of 32 de Gao-en, 137 de Giroe. He noted 4 confirmed detonations. He surfaced after the escorts had cleared the area and resumed his patrol. Shinano's wreck lies where she fell, 65 nautical miles southeast of Honshu, 1,400 meters down, undisturbed, unrecovered. The largest warship ever sunk by a submarine, resting on the floor of the Philippine Sea. Commissioned on the 19th, sunk on the 29th, gone before December arrived. 17 days, not one aircraft launched. The wreck of Shinano has never been located by modern survey vessels. No underwater expedition has reached her. She lies in approximately 1,400 meters of water in a zone of the Philippine Sea, where ocean floor surveys remain incomplete. Japanese naval authorities have not formally pursued a recovery or documentation mission. The 1,135 men who went down with her have no marked grave. Shinano exists in the historical record precisely. In Janak reports, in Archerfish's declassified patrol logs held at Nara under Record Group 38, in post-war interrogation transcripts of surviving IJN officers. But she exists on the ocean floor only as an absence. A sonar return that no one has yet gone looking for. What she left behind was not technology. It was not doctrine. It was not a design philosophy adopted by successor navies. Shinano left behind a question, the same question that procurement analysts and naval historians have returned to across 8 decades. And the question is this: at what point does a weapons program cross the threshold from strategic asset to strategic liability? The IJN's leadership in 1944 understood, at some level, that the war was lost. The Battle of the Philippine Sea in June 1944 had destroyed Japanese carrier aviation as an operational force. Leyte Gulf in October had shattered the surface fleet's ability to conduct offensive operations. The American submarine campaign had strangled the sea lanes connecting Japan to the raw materials her war economy required. None of this was hidden from the Naval General Staff. The intelligence existed. The analysis had been done. The conclusions were available to the men who ordered Shinano to sea on November 28th. They sent her anyway. Not because they believed she could reverse the trajectory of the war, but because they could not find a way to acknowledge, institutionally, that the trajectory was irreversible. Shinano represented 4 years of national investment. In steel, in labor, in engineering, in the identity of a navy that had defined itself by the scale of its capital ships. To leave her in dry dock, incomplete, was to admit what the battle reports had already proven. To send her south, even unprepared, even at risk, was to maintain the posture of a navy still capable of strategic action. That posture cost 1,135 men their lives. It cost Japan the largest warship she had ever built. And it produced, 10 hours after 4 torpedo hits, a sonar signature on an American submarine's passive listening gear that told Commander Enright everything he needed to know. The human footnote belongs to Enright himself. He returned to the United States after the war, left active naval service, and spent years uncertain whether his confirmed kill would ever be officially credited. The Janak process was slow. Documentation of Shinano's existence had to be assembled from Japanese sources that the IJN had deliberately obscured. It was not until 1947, 2 years after the war ended, that the formal confirmation arrived. Enright received the Navy Cross for the Shinano patrol. The citation described the action with characteristic understatement: aggressive and skillful attack. He lived until 2000, long enough to see Archerfish's record thoroughly documented, long enough to read the Japanese accounts of what his 4 torpedoes had found in the dark. The broader legacy belongs to the American submarine force. The Pacific Submarine Campaign, conducted by boats like Archerfish, by crews operating without fighter escort, without surface support, in waters where Japanese anti-submarine warfare was improving steadily through 1944, sank approximately 1,178 Japanese merchant vessels, totaling 4.9 million tons, along with 214 warships. Those figures come from JANIC's post-war assessment and represent the most devastating commerce warfare campaign in naval history. Shinano was not the campaign's largest strategic contribution. She was its most dramatic single moment. The night a submarine, no one had positioned for interception, commanded by an officer recovering from a previous failure of nerve, sank the largest carrier ever built with 4 torpedoes and 4 hours of geometry. The lesson the U.S. Navy drew from Shinano was not primarily about carrier vulnerability. It was about submarine utility, about what a well-trained crew, a capable weapon, and a commander willing to spend 4 hours solving a geometry problem in the dark could accomplish against a target that the enemy believed was beyond reach. The lesson the IJN's failure teaches is harder and more durable. A weapons program built on the assumption that size confers invulnerability, that mass and armor and engineering ambition can substitute for operational readiness, trained crews, and honest assessment of strategic reality, does not fail at the moment of combat. It fails in the dry dock, in the staff meeting, in the procurement decision, where readiness is traded for schedule. The combat moment only reveals what was already true. If you found this history valuable, give the video a like. It is the single best signal you can send this channel. And if you want more stories about the weapons programs and decisions that shaped naval power across the Pacific War, subscribe to Defense Archive. We will see you in the next one. Somewhere on the floor of the Philippine Sea, 65 nautical miles southeast of Honshu, the armored flight deck of the largest carrier Japan ever built lies face down in 400 meters of cold water. Commissioned on the 19th of November, sunk on the 29th, carrying 1,035 men and not one aircraft into the dark.